Hey everyone, welcome to another video. In this small section of the video, I'm going to demonstrate for you guys how to use zero-shot DeconvNet. And this approach is quite fascinating. In fact, it learns the underlying noise, and by way of learning that underlying noise in your images, it learns how to do the reverse of that, so decrease the noise. And it's a fascinating approach. It's a two-layered approach, and I won't spoil the exact paper for you, but go ahead and check them out. I'm going to leave the link down below, and in a short form video, I'm going to go ahead and present both the tutorial of how to get this set up on your own computer. You can use CPU to do this deconvolution. And the best thing is that you don't need to go outside of your own image data set. And these authors do a wonderful job of presenting their methodology here, and their GitHub support is fantastic. I left a comment. I needed some help with this yesterday, and today I have my answer, and I'm presenting to you guys, how to utilize this approach to do deconvolution for yourself. And you can see, and you can read their paper, and of course I will leave the link for that in the description of this video. But it's a fascinating world we are living in. Machine learning is it's creating so many wonderful things that are helping us to improve our everyday lives, especially as scientists. And so I will leave the link to all of this. Please check it out. And then in this small section of the video, so initially I want to show you guys how to get it set up. But before that, really quick side note for the developers of this GitHub repo, please add a license file so that other people know how to utilize your script and what they can distribute and under what license they should modify your content here. Okay, so please add a license and a citation file to your GitHub repo so we can all cite you and your repo, and also know what to do with the modifications that we make. So without further ado, let's get started. So for getting this set up for FIJI, you're going to need a few things. So you're going to need to figure out what kind of images you want to use. Do you want to use 2D wide field images? Do you want to do 3D, like light sheet microscopy, for example, or 3D confocal? Whatever kind of imaging that you want to do, you have to set that up. You have to figure that out. And what the authors do is they provide a lot of tools to help us get started. And one of the aspects that I want to focus on, and this was my troubleshooting, was that I had to figure out which archive version of FIJI to use with this project. And the one that worked for me is this FIJI Windows Win64 zip file. Okay, so you guys can, I will leave the link for this archive. Please go ahead and download this one, and then you will be able to follow along with this tutorial. So I've already done the downloading of this. I'm not going to go ahead and cancel this. I'm not going to repeat this because I have already done that. And I've also went ahead and downloaded the plugin. So if you come to their GitHub repo, there's a link here to download the plugin for FIJI. Okay, so they have the plugin and the jar files. You're literally going to download the plugin and the jar file. So for the plugin, you're going to put the plugin into your wherever you have your FIJI or ImageJ installed. You're going to go ahead and open up your plugins folder and copy the plugin from here. Once you have downloaded and you have a file that looks like this, you're going to copy this in here. And so for me, where does it go? Yeah, so here's mine. So I'm doing a search in that folder. It's in my plugins. And then same thing for the jar files. You're going to download all of these and copy them after unzipping the folder that gets downloaded. And then you will go ahead and put that into the jars. All of these will go into your jars file. or jars folder. Once you have done that, go ahead and open up your ImageJ. I run my ImageJ as an admin so that I have writing and saving privileges on my computer. So from this point on, what we need is we need to get our images. Here I have a folder. I've created this folder. It has some of my images, and I'm going to open up this sequence of images. Okay, it looks like this. I'm going to go ahead and crop just the area that I want. I am going to take a substack of this entire image like that. And I'm going to use this one to train my deconvolution net. Okay, we don't have to go outside of ImageJ to do this. First, you want to make sure that you have ZS-Deconv saved. So let me move up a little bit here. It doesn't get cut off. So here I'm going to go ahead and do train on opened image. And then this brings up my opened image. I have to make sure I have that. Wherever you're saving your PSF, so point spread function, wherever you're saving it, and if you don't have point spread function, the authors here provide a very nice tool to be able to generate your point spread function. So on their tutorial page for this, they have provided that some instructions on how you can make the point spread function computationally, how you can simulate, and that's in 2.2. In my case, I already have my point spread function that I calculated for my microscope, so I am not going to be utilizing their script. And if you are using FIJI, you will need the point spread function. So kind of either use the simulated point spread function, which they provide MATLAB scripts for. So you will need MATLAB to be able to create a simulated point spread function, or you can follow some other tutorials on YouTube and figure out how to do that for your microscope, how to get the point spread function. To make things easier for myself, I'm only going to run this for 100 epochs. And for iterations, I'm only going to do 100 iterations per epoch and decrease the learning rate just so we have less numeric instability, and press OK. And then from this point on, I'm ready to get the training started. Okay, and for this, for the next few an hour, I think it's going to take about an hour to get 100 epochs done. All right, the training is going pretty well, and I think I will stop it here. The losses have pretty much plateaued, and should be okay model. It's not going to be the best, but I already have another model trained, and I don't need this to be the best. So I'm going to go ahead and press this finish, and the training has stopped at epoch number 48. I'll go ahead and export the model, and this again you can export wherever you want, and I will put this one on, let's see, documents, and yeah, that's fine. This one in documents. Okay, so with that out of the way, I'm going to go ahead and open up my all of the images that I have. Test images like this. So this is what my stack looks like. I trained a 2D model because these are individual images taken over time, and I basically just want to deconvolute them one by one, and therefore I don't need the 3D. I don't need to train a 3D deconvolution model. So to predict, you just basically come here, you open up the zero shot plugin, and drop in the path to the model that you have saved. And so yeah, that's all you got to do, and press OK. It will start to process. If anything happens to come up, it will throw an error up here on the left to let you know that something has happened. For me, it's going pretty well. As you can see, it's running. So I'm gonna wait for this to finish processing all of the stacks that I have here, and then I'll show you the side-by-side comparison. All right, so the deconvolution just ended. It took this many milliseconds, and I'm going to close this console now, and let's take a look. So left one is the original, the right one is deconvoluted, and you can see some halos around those cells. Clearly shows that some processing was done. But overall, what do you all think? I think it's a pretty amazing tool that when more people use, we will learn more about refining parameters and how to utilize this in a proper format. It's a fairly new tool, only came out last year, and I'm very excited to bring this video for all of you and to show you how to utilize this. Again, I'm also a beginner to this tool. I'm still learning about many different parameters that go into making this UNet system work. So if you have any comments for me or suggestions for me, please leave a comment below. Give this video a thumbs up if you want other people to know about it, and please share your thoughts in the comments below. Thank you.